Okay, now one of the last pieces that we need are loops. Okay, so loops are where you run in a circle. And now when you look at the Arduino, you might say to yourself, well, you've got a loop down here, and this is actually a loop. It will loop absolutely no matter what, and you always have that for your use. But sometimes you want conditional loops, so you want something like a for loop or a while loop that will execute a certain number of times or only execute when things happen. The syntax for this for loop is very similar to other programming languages. You do a keyword for, and then you're going to provide a loop variable, and you're going to initialize it, and then you're going to say you're going to have a test, which you each time through the loop you'll see if it's made it to a limit. So, and then what you'll do is you'll increment or decrement the loop variable, and you can use plus plus. In this situation, you can use x plus plus, or you can use like x equals x plus 1, or x equals x plus 2, whatever. And then what it'll do is it'll go through the loop a certain number of times. Okay, so let's do an example of a for loop. So let me nuke all this, and I'm just going to flat out come in here and put a for loop straight in there. So let's go ahead and say, let's do a for loop that'll just print 1 or 0 through 10. Okay, so I'm going to go 4, and I'm going to have a loop variable, and I'm going to call it I. Okay, so I can define I as an integer right in the for loop. So this is kind of a popular way to do it. I mean, I just created I as a variable, and I had to tell it was int. I could have done int I up here, but I just decided I'm just going to throw it all in the same for loop. And what I'll do is give it its test condition, which is I is less than, let's say, 10, and then I'll do we'll do I plus plus, so it's going to increment by 1. Okay, so now what is this going to do? Well, here's what it's going to do. It'll go through this loop, basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 10, and for each time we can actually print it. So I'm going to say print with a carriage return I. Okay, so I'll go ahead and get rid of all this stuff up here that we're not using anymore, and let's see how this works. So this is pretty slick. It'll come through. Not so slick. I had a error here. Oh, sorry. Serial.print. Okay, and we pop that baby up. Okay, so it worked there. Life is good. And it's going to come over here, and it printed 10 times. Notice that I'm putting this in the setup scope, so it's only going to run one time. If I would have put it down here, it would have ran forever. And here, let me do that right now and show you how I could actually do it by run it by 2. So I don't have to always increment just by 1. I can increment it by 2. So let's fire this baby up, and it'll count 1 up to 10. And it's less than or equal to 10, and then it'll go into this, and it's going forever. So see how it's just flying along there, and that's because I didn't put delay. So let's put a 100 millisecond delay in there, and let's fire that up. So I'm feeling really good about my loops. Everything, I have a for loop. I'm going to use those like crazy. While loops are the other situation. So look at this here. Now it's popping away. Let me reset my Arduino and start from scratch here. So so see how it started with 1, 2, 3, 4, 5. Okay, so watch right here. It's going to start. It finishes what it's doing, and off and running. Okay, so oh, I didn't put the delay here. Is why it went so fast. Delay 100, and fire that off. Okay, so this is great. Life is good now, and it did the first for loop, 0 to 10, and then it started counting by 2s. Awesome. Okay, so let's do another loop, which is really popular, which is a while loop. So let me nuke the ever repeating one, and let's see how we can do a while loop to do the exact same thing. So I'm actually going to delete this entire thing, and I'm going to create a loop that'll count up using a while loop. So let's create a variable called j this time, and let's go ahead and initialize it to 0. And so I have this j, and what I do is I do while, and I provided a Boolean condition. Okay, so I provided a Boolean condition, and if it's true, it will execute whatever you list. If it's not true, it won't execute that. And so I'm going to come up here and I'm going to say while, let's go j is less than 100. Then what I'm going to do is I'm going to open up a curly, and I'm going to say print line j, and then I'll do a delay, and I'll do 100. Let's do 200, make it nice and easy. And then this will just sit there forever because the j is 0. But I can actually, within the while loop, I can actually increment this. So let's increment it by 3, for example. And let's think about what's happening here. So you're going to evaluate while, and you always got to have this serial in here. So let's pop that off and let's see how this goes. So it's going to evaluate, is j less than 100? If it is, it'll do this. If it's not, it will just skip this thing and be done. Okay, so it'll just sit there and be done. So when I have this in the loop, so look at how nice this is. It starts at 0, 3, 6, and it's going to go all the way up to 100. It did it, done, and it stopped. If I would have put this back down into here, I would have gone up to there, and then I would have started over and basically cleared the loop variable out and continued. So while loops are super handy. Okay, so while loops are great. Okay, so you got your loop structures. And fantastic. Okay, so everything is so great. So let's think about something really cool that I can do with a while loop. And that is, I can actually now read from the console. Okay, so how are we going to do that? So it turns out there is a function. So the problem with trying to read from the console using an Arduino is that the Arduino does not have the gets. Okay, so it doesn't have gets function. So because it's not a standard I/O, it's not a keyboard mouse like in a general computer. So it's not going to have this ability to just sit there and read from the keyboard. What you're reading from is this serial UART cable, or the USB cable. And the way that those works are, you can go out and you can read from it. So there is a function called serial read. Unfortunately, when you call that, it doesn't sit and wait. It just goes and immediately sees if anything has been sent, and unless it's being sent at the instant that you called the function read, it will just return a 0 and say, I didn't see anything. Okay. So this by itself is really worthless. However, when used in conjunction with the while statement and another function called serial.available, you can actually read from it. And so here's the logic behind it. What you're going to do is you're going to say, I want to have the user enter something from the serial monitor and then upload it to the Arduino. So you're going to say enter an integer. And then what you do is you do a while statement. And this serial.available, the way that it works is if something out there is not sending information, if there's no information on the serial port, it'll return a 0. So what happens here is this will sit in this loop until something is entered. Okay, so it'll just sit here, and this is a true situation. So it's just like sitting in these little curly brackets. Okay, and so you can think about it, this line of code is just executing indefinitely until somebody enters something. If you enter something, then this function will say, hey, there's something there, and it won't return a 0. And that'll allow you to come out of this function, and then you can do something. So what we will do then is we will use this serial read, and we will assign it to a variable. And then what we can do is print the variable and see what happens. Okay, so let's try that. So let's go in here and let's go back to our code and let's take a look. I'm going to put this over here so I can see the do it. So the first thing I'm going to do is I'm going to make a car, which is going to be VN, and I'll go ahead and I'm not even going to initialize it. Okay, so I'm just going to sit there, and then what I'm going to do is I'm going to go serial print. I'm going to say enter an integer. And we'll think about this here, what that means to enter an integer. It's actually received as a character. And what I'm going to do is I'm going to say while, and then serial.available, and it's a function, equal to 0. And then I'm just going to sit and spin. That's it. So it'll just sit there until something's available. And then what I'll do is if it ever is something ever comes up the cable, I will perform my serial.read, and that will assign it to that car variable vn. Okay, and then just to verify that something happened here, let's go ahead and say you entered blah, and I'll go serial.print vn. And it would be handy to do this over and over. So why don't I go ahead and let's do this. Let's put this down in this loop so it'll go forever. So once this is done, it'll say enter an integer. And then in order to see this variable amongst everybody, let's go ahead and pop it as a global. All right, so now I'm sitting here and I'm going to go ahead and fire this up, and we'll see what happens here. All right, so let me pull up the serial monitor as we're going here. And now we're sitting here. Enter an integer. So one of the things you notice is that if you click in the serial monitor and you try to type something, nothing happens. The way that you send something up is you have to actually put it in this little dialog box. So if I'm going to put 7 up here, and I have to actually send it. So I hit send, and it says you entered 7, and then it says enter an integer. So that was great. Okay, so life is good, except that my returns didn't work very well. So I'm going to say enter an integer. I'm going to print that as ln. And then I'll do this one, you entered, and then I'll do ln there. Okay, and let's run this one last time, and let's make sure that everything's cool. And life is good. Okay, so I'm coming along here. And what I want to show you is the difference. So enter an integer. So let's go ahead and send 7 up again. It says you entered 7. Enter an integer. I'm going 9. Life is good. 4. Check this out. I'm going to type G. It says G. Okay. Well, it's fine. It's because it's a character. What would happen if I came up here and I made this variable vn an integer? Okay. So when I read it, it's going to say you're going to send something up the cable, and it's going to interpret it as an integer. And since Arduino is going to allow us to use print right away, print on the variable and automatically figure out what type it is, what'll happen? So I don't know. I'm going to send 7 up and see what happens. You entered 55. That's kind of weird. What about 8? You entered 56. What about H? 104. What do you think's going on here? I'm typing it, I'm sending these characters, and it's giving me these weird responses. You know what it's doing? What comes up the cable is an 8-bit ASCII code for the symbol that you send. So when I say B, it's going to go look that up, and it's going to say, oh, the 8-bit code in decimal form for the symbol B is 98, and it'll pump that out. So you got to really make sure you pay attention to when you use the serial monitor to collect data, it's coming up as an ASCII character. If you wanted to use these as actual numbers, you would have to I would take it in as a character, and then I would convert from a character to an integer. Okay, so go ahead and play around with that. Do a for loop, do a while loop, use a for loop to go 1 to 10, print 1 to 10, use a while loop to do 11 to 20, and then use this while loop and this serial.available function to read a character from the serial monitor. That's going to be a big one. I mean, that's something that you can use like crazy. So go ahead and play around with that, and pause the video and see how it goes.